the world is making this huge shift, I mean, a massive shift towards renewable energy.
Yeah.
And solar power. It's right at the front. But it needs, well, structural perfection to really work at scale. We often talk about panel efficiency, the tech inside. But today, we're going straight to the skeleton, the actual materials holding it all together. So we're diving deep into aluminium solar profiles, basically the backbone of this whole movement. Our mission really is to figure out why this material, aluminium, is so critical, why it's transforming renewable infrastructure, and honestly, why it seems to have won the structural fight. What we found is pretty clear. Aluminium hits that sweet spot: strength, durability, adaptability. It bridges the gap between like a good sustainable idea and putting it up everywhere reliably.
And just so we're all on the same page, when we say aluminium solar profiles, what are we talking about? These are specially designed structural pieces. They're made using extrusion, pushing aluminium through a shaped die, and they form the foundational skeleton for the mounting system. They're what holds those millions of solar cells securely, whether it's just a few panels on your roof or a giant solar farm out in the desert.
Okay, let's unpack this then. Because, if you're building something big, something strong that needs to last, you might first think of traditional stuff like steel, right?
Yeah.
Or maybe even some advanced plastics. So why aluminium? Why has it become the sort of go-to choice for engineers and developers all over the world? What's its unique edge?
Yeah, it really comes down to performance versus cost. But importantly, not just the upfront cost, we're talking the whole life cycle cost. So look at steel. It's strong, no question, but it is so much heavier. And that just complicates, everything.
Like getting it to the site.
Exactly. Transport, installation, even just engineering the roof to handle the extra load. I mean, imagine a utility scale project where you're moving literally thousands of tons of material. That weight penalty, it's huge. It slows things down, impacts safety.
Okay, so weight is one major thing.
And then the real kicker, I think, is corrosion. Steel just wants to rust. It's inherent. So it needs extra steps galvanizing, special coatings, regular checks and touch-ups just to survive out there. Aluminium, though, it naturally forms this protective oxide layer, so it's inherently corrosion resistant.
So hang on, if I was, say, building a solar plant right on the coast, somewhere humid and salty like Florida or, Dubai, and I tried to save a few bucks up front with maybe cheaper steel profiles, I'm basically signing up for decades of hassle, right? Expensive maintenance, coatings failing.
That's exactly it. You're locking in those long-term operational costs. The aluminium profile, on the other hand, it just sits there. It shrugs off the salt spray, the humidity, the rain, for potentially 30 years or more with minimal fuss. And that drastically cuts down your maintenance budget over the project's life, which, let's be honest, is the metric everyone cares about in renewable investments. The long game.
Okay, steel's out for those reasons. What about plastic? You mentioned plastic. Cheaper, maybe?
Yes, cheaper initially, but plastic components, they just don't pass the test for strength and critically longevity in this application. They simply lack the load-bearing capacity. Think about it. These structures have to withstand intense sun, heat, sometimes heavy rain or snow, and definitely high winds for decades. Plastic just isn't up to that task reliably. Aluminium, it hits that ideal balance. You get the strength you need, the longevity, and when you factor in the low maintenance, the overall cost efficiency works out.
Right. That structural performance is clearly pillar number one. And you mentioned lightness earlier. Beyond just making it easier for the installation crew, how else does that lightness really pay off?
Well, that combination, lightweight yet strong, it's kind of revolutionary for construction. Aluminium gives you excellent load-bearing ability without all that dead weight. For big installations, this means faster logistics. You need fewer trucks to move the same amount of framing. Handling on site is easier, safer. It speeds up the whole build, which saves money and reduces risk on these mega projects.
Okay, so the key features are boiling down to long life, low weight, stands up to the weather, structural stuff. But that raises the other side of the coin. If we're building sustainable energy infrastructure, surely the frame holding it all up needs to be sustainable too. Does aluminium fit that picture?
Oh, absolutely. And this is what's really fascinating, I think, how well the material itself fits the whole renewable vision. Aluminium is 100% recyclable.
Fully recyclable, without losing quality.
Yep, without losing its inherent properties. So when a solar installation eventually reaches the end of its life, maybe in 25, 30 years, that aluminium can be melted down and reused to make new profiles or anything else. This directly fills into that idea of a circular economy, which is so important for the renewable sector, and it gives developers a real way to lower the overall carbon footprint of their projects. It's an eco-friendly choice that's also durable. Win-win.
That's impressive. And you mentioned earlier this utility comes from how it's made.
Yeah.
Extrusion technology, right? That's key.
Yes, exactly. Extrusion is what unlocks so much of this potential.
Yeah.
Because aluminum is so workable, manufacturers using extrusion can create really sophisticated, innovative designs. It can be pushed or extruded into incredibly complex shapes, custom shapes tailored precisely for different types of solar systems, different mounting needs.
And how does that help on the ground?
Well, that design flexibility means engineers can optimize everything. Optimize for space on a crowded roof, improve airflow around the panels for better cooling, enhance overall efficiency, and because these complex profiles can be made precisely, things fit together perfectly on site. That cuts down installation time, reduces labor costs, fewer mistakes, faster build.
So if the material is that flexible, how do architects or engineers know what to specify? I mean, are we talking different profiles for, say, a simple house roof in a calm area versus a huge windswept solar farm? How does that work?
Absolutely, the application drives the design. We generally categorize them based on where they go and what their main job is. So first you have the real core pieces. We call them solar structural sections. Think of these as the main beams, the foundation. They're engineered purely for strength. Their job is to support the weight of all those panels, to handle the wind load, snow load, whatever the environment throws at them, and ensure the whole thing stays stable for decades. High strength to weight ratio is critical here.
Okay, those are the heavy lifters. But they don't actually touch the solar panel itself, do they? What protects the panel?
Good point. That's where solar module frames come in. You see these on every single panel. They're the slim aluminum profiles that go right around the edge of the glass module. Their job is protection. Shielding the panel edges from getting chipped or damaged during handling or installation, keeping moisture out, managing thermal expansion, which is a big deal in places with extreme temperature swings. And because they're aluminum, that natural corrosion resistance is perfect. They're constantly exposed, right? So they help maximize the panel's own lifespan and efficiency.
Got it. Structural sections for the base, module frames for the panel edge. Then you mentioned placement roofs versus fields. Big difference there.
Huge difference. For roof-mounted profiles, the key design constraint is usually weight. You need them to be strong enough, of course, but also extremely lightweight and compact. This is crucial for putting solar on existing residential or commercial buildings. Flat roofs, sloped roofs, doesn't matter. You absolutely have to minimize the extra load on the building structure.
Right. Don't want to cause problems for the building itself.
Exactly. Now contrast that with ground-mounted profiles. These are engineered for pure brute strength and endurance. They're built for those massive utility-scale solar farms you see sprawling across open land. These profiles have to be incredibly sturdy. They're holding up huge arrays of panels, they face potentially much higher wind uplift forces, and they need to cope with different soil conditions, maybe ground heave. They're built tough.
And then you get the really spiralized stuff, the custom designs.
And right, the custom solar profiles. This is where it gets really interesting for architects and designers. These are tailored solutions for specific, often unique needs. Think about building integrated photovoltaics BIPV, where the solar panels are actually part of the building's skin, like a facade or skylight, or maybe really complex roof shapes on architectural showpieces. For these, you might need custom dimensions, a specific surface finish, unique load-bearing specs. Aluminium extrusion makes that possible, delivering both the needed strength and the desired look.
That adaptability really is something. It feels like these profiles aren't just holding panels up, they're actually enabling new kinds of sustainable architecture. So, zooming out again, what's the real-world impact? How is this material shaping the big picture of global renewable projects right now?
Well, it's pretty much essential across the board. Take those huge utility-scale solar power plants. Aluminum profiles provide that critical long-term structural stability. They ensure those massive ground-mounted systems keep generating power reliably for, 25, 30 years or more. That kind of dependability is priceless for grid stability.
Makes sense for the big farms. What about in cities?
Yeah, in urban areas, it's crucial for rooftop solar. Its lightness and design flexibility mean you can integrate solar onto existing buildings much more easily without adding dangerous amounts of weight. It helps make urban solar viable.
And our source material actually highlights a specific example of this scaling up globally. I mentioned India.
That's right. India is a great case study. They have this massive national push for solar energy backed by strong government policy. And that huge domestic demand has really accelerated the learning curve for their local manufacturers. They're now producing high-quality, precision-engineered aluminum profiles, not just for India's own huge projects, but they're also exporting them.
So they're meeting tough international standards now.
Exactly. It shows the whole supply chain is maturing globally. Expertise is growing, and high-quality profiles are becoming more widely available, which helps bring costs down everywhere.
Which points to the level of professionalism needed here. Okay, let's bring this back to the listener. To you, if you were in charge of specifying materials for a solar project, could be a giant farm, could be your company's roof, could be one of those unique architectural integrations, what are the absolute must-check, non-negotiable factors when you're choosing profiles and suppliers? Three key things.
Yeah, based on everything we've seen in the performance data and project requirements, it really boils down to three critical things. Purely performance and reliability driven. You just can't compromise on these. Okay, number one, absolutely essential, load-bearing capacity.
Yeah.
This is all about safety and long-term performance. You must verify that the profile is engineered to handle the specific loads of your site. That means the maximum expected wind speeds, snow load if that's a factor, even potential vibrations. Can it handle all that without bending, warping, or failing over decades? This is non-negotiable, especially with the size of installations today.
Right. Back to that coastal wind or heavy snow scenario, it has to be rated for the actual conditions.
Precisely. Okay, factor two. Make sure the profile matches the type of solar system. It sounds obvious, but the profile must be engineered for the specific job. You wouldn't use like a sleek, lightweight profile designed for a BIPV facade on a heavy-duty ground mount system that needs to be embedded in concrete, right? It's about precision. Lightweight and compact for roofs, super sturdy for ground mounts, custom engineered for anything hybrid or unique.
Choose the right tool for the job, basically.
Exactly. And finally, factor three, supplier credibility. Look, the best design in the world doesn't mean much if the manufacturer can't deliver it with high precision consistently. The performance and longevity of your entire multi-million-dollar solar asset depend on the quality of these profiles. So you need to look for reputable aluminum extrusion manufacturers.
What does reputable mean in this context?
It means they have proven expertise, ideally backed by third-party international certifications. They should have a track record. And importantly, can they provide both standard profiles and reliably execute complex custom orders if needed? Their manufacturing capability and quality control are paramount.
Load capacity, system type match, supplier credibility.
Got it. That's incredibly practical. It really connects the material science we talked about to the high-stakes decisions made on real projects. It's clear aluminum solar profiles aren't just a component. They're fundamentally enabling efficient, durable, long-lasting solar installations all over the world. They're revolutionizing the infrastructure. Yeah, and if you connect that back to the bigger investment picture, that inherent corrosion resistance we talked about, it means these installations maintain their structural integrity and keep performing efficiently for decades with less upkeep. So aluminum isn't just like a piece of metal in the system, it's a long-term sustainable investment choice in itself. And that raises, I think, a really interesting comment for the future, especially for developers and investors, knowing how long these aluminum structures last, and knowing the material is fully recyclable at the end. Just how much lower can the life cycle cost of solar energy actually fall as aluminum extrusion technology keeps getting better, designs get smarter, and maintenance needs potentially shrink even further?
That is a foundational question. How low can the true cost of solar go? Something for you to think about as you watch the sustainable world being built, quite literally, on foundations like these. Until next time.